So folks, we're actually supposed to be on this Mega Trekker CB1100. It's the kind of last ditch attempt at getting the IF right on the receiver, but I've had a more normal customer repair and I need to get that out. Being ill at the moment, it's been here too long. This is a long stay, so that doesn't matter. So we'll put it on one side yet again, and we'll do this Amstrad. So one of the things he wants to do is to sort out the power connector. As you know, we do the correct plugs for this square round type of these, but not all the sets are square round. So if you've got the thinner one, you can file it out so the square round fits. If you've got the fatter one, well, you can either glue gun it in, or we have an adapter plate which one of our viewers has made. You can also buy one from us off eBay and leave neutral feedback, because it doesn't fit, despite being told that you need to make sure, absolutely sure, that what we're selling fits your radio. You see, if people say, oh, mine's too fat, I can then say, well, we do an adapter plate. But you can also leave neutral feedback, and then you don't get any help, do you? Right, so it's a made in Japan original. I'm going to have to leave this in for now while we fix the set. I'll get Mr. Chippy to make a tail up, and then we'll discover which version it is. I don't honestly know. Looking at that, it looks, to be honest, it looks like the square round correct one. But there's so many others. What's this scrap set here? See, that's the same. There's one here. That is going to be the one that it would fall inside. It's the two factories. It's the Mustang. It's the early production one. So that's a situation. As you can see, it's too wide. So you've either got to glue gun it from the rear, or you put an adapter plate in, which I say one of our viewers has made. Anyway, I'll show that. I've shown the adapter plate before, but on the communicators. And then he only wants 50p for them. It's not like it's a big deal. Not that he says he doesn't want to be making millions of them, but it does get people out of the quagmire. Right, let's get it powered up as it is. And we want a standard replacement mic. I've got a pile of them on here and I'm not quite sure why. I've got the grate. Comtron is the one we use for all those Maxcom Midlands with the 5-pin. We've got DNT. I was going to do a DNT set, and I took one look at it and didn't feel well enough. So usual things for this is we get 3.6 watts, then that's fine. If we don't get 3.6 watts, we'll change the ballast resistor. See how loose this connector is. It doesn't look loose at all. If you saw one of those on the air test we had to curtail recently and then restart, it's because the leaves in the aerial socket can stretch. This customer's got quite a few of these Amstrads, and he's even got a fake one. Right, I'll go and get a sheet of paper and we'll write down the parameters. Right, here we go. So we're on channel 20, we've powered up. Let's put picture in picture on, if I can find the right switch. We're on the 3 watt scale. It's gone beyond 3 watts. 3.1. And on channel 40, 3 watt. Channel 1, 3.1. Back to 20. Check it on low power. 200 milliwatts. Not adjustable, you get what you get. And the current consumption on full whack is 1.418, which is a lot for 3 watts. Deviation, see whether this is playing ball today. Wallow, says it's 5, and I believe it. Let's do the VCO. Pop it on channel 1. One of those, this chassis is one of those that you do need to check the VCO from time to time. Right, 2.5 on channel 1 on receive, and 0.57, 2.1 RX, 0.57 TX. Right, well that's not right. So it's supposed to be 2 volts. I can never remember. So in receive we've got 2.5, so we just need to adjust that for 2. And in transmit we also need to adjust it for 2.4. So it's not even transmitting now. I've turned that one. Right on the verge. I think we'll have it at 2.1 and 2. Just over 2 for receive. 2 plus 2.1. Check it on channel 40. But it's actually in lock. Let's transmit. That's receive. That's fine. Good. Well, that one needed doing. So the lower channels we're about to disappear. It certainly would in different weather temperatures. So it's now 2.1 RX, 2.1 TX, and we'll leave it at that. While I'm at it, we might as well look at the frequency and deal with it accordingly. Oh, we're still on channel 40. Right, channel 27799092. 27799092. So although it'd be nice if it comes up, it isn't off frequency at that, and it isn't illegal at that. So let's hope we can get it up a little bit, otherwise it's changed the reference crystal. But if that's as far as it goes, that doesn't matter. It goes to 27110. We'll check that later, and I'll write the figure down after the test equipment's been on a bit longer, because it will rise. So that's fine. But we'll set at the moment we'll set the signal generator to the same 2779110, so it's an absolute fair reading we're getting. Right, let's put the test equipment in to the extension speaker socket, if that's the right one. Bit of noise on volume controls. The others are alright. So let's go over to the sine nav meter and see what we've got. Usually get better than that. 0.58. .48, 20, 1.5. Squelch. Only let down on the chassis as a whole, but on the genuine one at least it does work. We're looking at 2.3 millivolts, that's very tight. And at threshold, switch that to standby, set the radio, squelch threshold. Actually, 0.35. So despite it being quite tight, its sensitivity is there. Anyway, that'll get adjusted, but it might be because the something's out of alignment. So the RF meter, the radio's doing 3 watts. It's doing 5 bars for 3 watts, which is a bit daft. And for 100 microvolts, the radio is doing 30 microvolts for very generous. Let's check these switches work. I'll plug the PA speaker in. Testing 1 2, testing 1 2, testing 1 2 3 4 5. Testing 1 2, testing 1 2, 1 2 1 2. Need to clean those, that's what the problem is. So, sockets are okay, PA's okay. See if the rshireby works. Okay, walkie-talkie on the job. Switch the rshireby on. Yep. Channel 9 switch does that, yeah. Good. Right, start with the transmitter. And see if we can get to magic 3.6 or whether we're going to have to change the ballast resistor. So back to the usual problem, these are 3 watt rated. So it's only 50% of the time you get 4 watts output with it being like that. Sometimes they're even skinny at 2.5 watts and just get hotter and hotter and hotter as you go into transmit. So let's see what happens. So we're on channel 20. Let's go back to the main meter. I've got a Mustang 3000 I want to show, and we had that boxed one in a few days ago, so I can't really show that. It will be surplus, it'll be one we could flog, but it won't be cheap. Right, so we'll go to the 4 watt scale, which is doing 4.1. So it's the centre of the peak, which is there. Centre of the peak, that was correct. And that's now 3.2 watts, so that one wasn't correct. I want some more heat. That doesn't seem to be fitting correctly. Why is that? Is that because it's a broken core? Yes, Mr. Tango, it's because it's a broken core. Ah, dear, here we go. Right, we better unsolder that. Let's hope this is the only broken core. Now, it may be possible to recover this by taking the core out the other way. The trouble is the debris in the top jams the threads. But hey, there may be enough to put it in the other way around, and we may pinch one if there is one. Look at 2 chassis. Oh, it's still intact on that one, and it's a genuine set. Well, I mean, we buy sets like this, so what happened to a set like this to get scrapped. Oh, the answer is probably it got reverse polarity when somebody lost the power lead. Good, well. Right, we'll solder that back in. Forgot what it's TX coil core. I think it's probably the same as those ones used in the other Cybernet, the 134 sets, which Knight still have a small stock of. I think the 150 a pop. Right, let's see whether we can get more than 3.2 watts. I'm sat here with this mic, not plugged into the radio, and I tell you what, there's something else needs doing to this, and that's this needs tightening up. That one's alright. Same thing with the aerial sockets. It was alright on this one, but the mic socket's was a bit loose. Okay, try again. Into transmit, we're doing just under 2 watts. Obviously that's not right in the correct place. Still 3.2, so it was broken in the correct place, but you can't let that go because you don't know that it's in the right place if it's broken. This is broken too. Just see whether I can get it out without having to unsolder it. You see it may be jammed like the other. No, I'll have to unsolder this one as well. This is going to be fun, isn't it? You know, these tools, these correct tools, are readily available from AliExpress. You don't have to resort to a carpenter's screwdriver. I did go to the doctor's yesterday and my chest infection, throat infection, brain infection, whatever it is, it's heading in the right direction. I had a letter from the hospital this morning for a chest x-ray appointment in 2 weeks, and the doctor's surgery said to me, expect to have a nasty cough for another 10 weeks. So I won't be looking forward to the wedding on Saturday, trying not to cough. There we go. So same again. Can we get a tool in underneath? All this extra work that the screwdriver experts cause. It's probably in the right position anyway again, but there you are. Right, I think we're 2 in this set. I bet these were broken within a month of the set being new, you know. This is tighter than I'd like. And it's 24 point something degrees in there. I could do with putting the air conditioning on. It's moving a bit, but it's not happy. Right, yeah, that's soldered back in. I'm losing my voice. I'll just solder that one. I'll just then make sure I'll push it in. And then we'll solder the other two. I bet the customer wasn't expecting any repair work whatsoever to this, apart from the connector. Right, power it back up, put it into transmit. So we're just doing 2 watts again, so get that in the correct position. So it's doing 3.4 watts, which isn't good enough, so out comes the ballast resistor. Anyway, we've gained 1/3 of a watt. Right, let's have a look in the bag of Amstrad resistors. There's quite a backlog of ordering these. I mean, 9 months between ordering them and they're arriving, even though they're made in the UK. How does that work? I don't know. The one. Put 2.8 in on this one. So let's clean the lead a bit. Put the sister flex on. I've said before, if you ever come across one and somebody's been daft enough to take the ballast resistor out, do reinstate it. I've done the demonstration before, but you end up with 2 watts on 27 megs and 4 watts on aircraft band. So you put it on a cheap power meter and, oh, I'm getting 7 watts, but you are, yeah, you are, but not on 27 megs. The last thing you want is to be dragged out in by the Civil Aviation Authority or the military. Right, see what happens now. 4.2 watts. So we need to make sure this is peak. It is. Just drop that to 4. Like that. And channel 1. Slightly high, 4.05. Channel 40, nowhere near right. So which one isn't right? It's not that one. It's that one. Not quite 4 watts, 3.8, channel 1, 4.0, so we'll just drop that again. That's 4. And that's not quite. It's going to be a fun one, isn't it? It's not that. It's not that. It's not that. What if one of these isn't in its correct position? Right, channel 20, 3.95, channel 1, 4, channel 40, 3.9. Mind you, the set's red hot, isn't it? Channel 20, 3.95. Channel 1, 4. Channel 40, 3.95. Now this will be higher when it is cold, but that's what we'll write it down for now. Current consumption on channel 20 is now 1.55. So we've only gone up, what, 100 milliamps to give us another 0.9 of a watt output. And on low power, is it worse or is it better? Sometimes it's worse. Spot on 200 milliwatts, the same. Right, I'm going to take a break, but before I do that, we'll just check the deviation with the other test meter. Then when I come back we can do the frequency properly. If I pick my prescription glasses off the floor, I might be able to read the meter. Wow, good grief. Showing beyond 7 on this one. It's wider, not louder. Wallow. That's now 6.5p. Any person will sound louder to somebody on a Fidelity 1000. We'll see what the Marconi makes of it now. Wow, it's the same. Good, that's warmed up right. Right, I'll come back in a bit. Okay, so let's see where we are now. I want to get the transmit LEDs to correspond to the power output. Let's make sure we're in transmit, which we weren't on the test set. We're on low power, aren't we? And it's 4, and there we are with the 4. Good. Right, the next thing, do the receiver. .100 microvolts on the signal generator. And we'll look at the oscilloscope. Actually, I think we're better to check whether the radio is on frequency first. So was it 119 we left? It wasn't far out anyway. 79120. So that's fine. So it'd be nice to bring it up to 125, but it doesn't matter. And this is as far as the crystal will go. Probably do another 10 years before you need to change the crystal. Right. So we'll set the signal generator to 2779125 to 120, sorry. To correspond with the radio, if I can speak. There we go. Right, we'll put the oscilloscope up. And see where we are with the detector. Which is hiding somewhere. I bet this one's never been fiddled with. Tell you what though, it needed adjusting. Right, we'll drop the attenuator. Put the cyanide meter up. And go through the front end. A little bit of an improvement there. A little bit of an improvement there. A little bit of an improvement there. They all add up. So now we'll look at these IFs. Bit of an improvement there. Bit of an improvement there, and finally no improvement with that one. Let's get a new reading. It's for 12 dB. We've now got 0.35, which is a bit more where you'd expect. 10 dB, 0.3. I could have said 0.295, but we'll keep it at that. And for 20 dB, 0.88. Now the squelch. That might have altered, it might not. Put it on full squelch. And we'll put the attenuator up on the inset picture. 1, 3, 10, 30, 100. It's about where it was, so we'll just do the squelch adjustment. Drop my mic on the floor. Adjust that to open at 100 microvolts. Yep, that's fine. So we've got 100 microvolts now on tight. And now we'll drop the squelch to bottom, switch the signal generator to standby, park it at 0.3 microvolts, set threshold on the radio. I do need to spray these. There we go, switch the signal generator back on. Straight in at 0.3. Really good. So if you have the cheap Hong Kong fake El Cheapo version, it's the squelch, which is a letdown. You'll often find, along with the Midland 77104D and the 805D and the 095 and the 099, that if you've got no aerial connected, the squelch doesn't open. Oh, it's faulty this, but it isn't. As soon as it sees any signal at all, the squelch then works. But it's a bit disconcerting if you've not come up against that before. I've said before these were intended for FM stereo hi-fi tuners. It's got built-in muting between stations. Good. Well, we're done. Apart from, S meter. So we should have S9 and we've got plus 30. There we go. Simple as that. Slightest touch. We can increase the signal, we'll get plus 30. There we are. So that's then correct. That's 4. So I'll now get into, I'll just get Mr. Chippy to make up a tail and a power lead. And Bob's your uncle. In fact, he doesn't need to make a tail, he can put a new connector on the lead that's already there. Just check the diode's in place. Yes, it is. Just going to check the diode's effective. So if the protection diode fails on these and you reverse polarity them with no fuse, well, you destroy every chip in the set. I don't think the protection diode's working. It's interesting, it doesn't show up on the... Perhaps you've got to turn the set on these. Anyway, I read it in situ and it's working. Right, I'll get Mr. Chippy onto this. Okay, so back with this, Mr. Chippy has done it. It's power tail and there's a power lead. So as you can see, as I was saying at the beginning of the video, these are the correct mouldings. They're not something pretend. These are the correct mouldings. They were black originally, but the current production they're white. So that fits, of course, perfectly because it is the right moulding. So what I was saying to you was there's also this other version. So again, that's the correct one with the little notch in it on that scrap chassis, and then there's this one on this Mustang, which is very early production and uses one of the other types of connector. There's a third one also used on the, which you'll come across especially on the fake Amstrad. So in this case, and this must be what the person who's bought the set, the lead from me and then left neutral feedback, obviously this doesn't work right because it just falls through. So you've two options. We've got an adapter plate which you would have to, it's a plastic thingy, what do you call it, 3D printed plastic plate, and you've seen me use it on what was it, Communications I440DX. So what you'd have to do is there's two screw holes and you'd have to screw it on, and with self tappers or nuts and bolts, whatever you want to do, then it would fit perfectly. But what we do is we simply glue gun it on the inside. We get the polarity right, so it's because it does have the polarity on the stamped on the case. So that's the third type. The second type I haven't got here, I don't think. Hang on, I can see one. What's this? That's the other one, isn't it? This is the other type. Oh, good. Yeah, this is the other type. So that's the one which is too fat. Oh no, these are both the correct one. You can see they're fed in from the inside. I'm not going to do it, so it's going to be a swine to get out. Now there's another one which is thin, and you have to get a bit of a needle file so you can fit one of these. But they are mostly this type. And those other two, they're obsolete within a year. But there you are. I just wanted to show you that we do have these connectors, and they do fit 99% of the sets. But don't order one if you don't have the right aperture, or if you do, you have to think of either glue gunning it in or asking me nicely if we can supply a 3D printed plate. Right, we'll initially test this with my usual connector crocodile clips. He says he bought this off eBay. Certainly needed some service work. It's had a do not remove sticker from somewhere, but it's certainly been well screwdrivered. So this is the original Cybernet 002 version, 002F. Oops, not the Hong Kong one and not the fake Hong Kong one. And for the first time in its life, it's actually doing 4 watts. Mr. Chippy's raring to go. And it's on the air test time and I'm losing my voice. Right, handy crocodile clips. It does say positive and negative on the case. Wait, power's up. And let's hope that the internal speaker isn't faulty. That's not the right mic. That's the right mic. It's better. Right, I'll switch the test gear off. Plug the aerial in. Woke it up. One niner Roger. Take the bleep off for now. Somebody's out there. It's about 20 past 6. $19 Roger. I do get a reply about every 200 calls. Right, we'll do an on-the-air test with that. And I'm sure it'll work beautifully. Thank you for watching the Amstrad 901 genuine original Japanese £89.99 version from 1981.